Now, let's do question 5. It says, the diagram shows a field ABCD. The bearing of B from A is 140, C is due east of B, and D is due north of C. AB is 400 meters, BC is 350 meters, and CD is 450 meters. Now in part A, we need to find the bearing of D from B. So from B means B is my start point. So I need to be at B. So from B means I need to draw a north sign at B. And the bearing of D from B means I need to move from B, from the north sign at B, in a clockwise direction until I meet the line connecting D and B. So this is the bearing. Let me call it X. And how can I find X? Now, can I find the angle here? Let me call it theta. Of course, yes, because this is a right angle triangle. So I can use tangent theta is the opposite side, which is 450, divided by the adjacent side, which is 350. So theta is tangent inverse of 450 divided by 350, and the answer is 52.125. Now that's not the bearing, that's the angle theta. Now to find the bearing, now since the north sign makes an angle of 90 degrees with the line BC, so this angle here is 90. To find X, X is 90 minus theta, which is 52.125. So X, which is the bearing, is 90 minus 52.125, and the answer is 37.875, which is equal to 37.9 degrees. So that's the bearing. Now, let's do part B. So in part B, we need to find the distance from D to A. So the distance from D to A, it's this distance, which is DA. Now, let me draw this triangle. So here I have AD. So let's call this point P. So I drew the triangle ADP. And this angle over here is 90 degrees. Now how can I find the line or the length of the line AD? Now if I know the length of AP and if I know the length of DP, I can use Pythagoras theorem and to find the angle or to find the side AD. So let's find the sides DP and AP. Now if I want to extend the line here, the north sign, I'm extending it. So this north sign makes an angle 90 degrees with AP. Now, can I find this angle here? Of course, yes, because this angle here is 90 degrees. If the whole angle is 140, so 140 minus 90, this small angle, acute angle, is 50 degrees. Now, yeah, so this is 50 degrees. Now, let's call this point here ABC, D, so let's call this point E. Can I find the line or the length of the line BE? Of course, yes, because I'm given the hypotenuse, so this is a right angle again. I'm given the hypotenuse, which is 400, and I'm given an angle. So I can use sine 50 is equal to the opposite side, which is BE, over the hypotenuse, which is 400. So BE is sine 50 times 400. So let's find BE. So BE is equal to sine 50 times 400, and the answer is 306.4177. Now I found BP, or sorry, BE. We found BE, yeah. Now, can I find DP? Of course, yes, because I'm given DC. So this 450 meters is the length of DC. So if I do DC, so this is DC minus BE. So here I have, so this point is E. So if I do 450, which is the full length of DC, minus BE, I'm going to be left with DP. So what's DP? DP is equal to 450 minus 306.4177. So DP is 450 minus 306.4177, and the answer is 143.58. So that's DP. So we found DP. So how did we find DP? So I have the full length of DC, which is 450 meters. I subtracted the length of the line BE from 450 to find DP. And we found BE by using the sine rule, or the sine ratio, which is the opposite sine, the opposite side over the hypotenuse side. So sine 50 is the opposite, which is BE, over the hypotenuse, which is 400. So I cross multiply to find BE. Now, can I find AP? Of course, yes, because AP, now part of AP is 350 meters. So I need to find AE, so this line AE, and add it to 350 meters to get the full length AP. Now, how can I find AP? Simply by using the trigonometric ratios, because I'm given the angle, which is 50, and the hypotenuse, which is 400. So I'm going to use the cosine ratio. So cosine 50 is the adjacent side, which is AE, over the hypotenuse, which is 400. So AE is cosine 50 times 400, and the answer so AE is so this is the opposite, adjacent, so it's cosine 50 times 400. So let's do that. Cosine 50 times 400, and the answer is 257.115. So that's AE. Now, to find the full length AP, I need to add AE to 350 meters. So AP is basically 350 plus 257. So it's equal to 607 meters. Now I found the length of AP, which is 607. So let's draw again the triangle ADP. So this is ADP, this is A, this is D, this is P. So A, D, P. Now DP is 143.58 and AP is 607. So can I find the length of AD? Of course, yes, by using Pythagoras theorem. So AD squared is equal to 607 squared plus 143.58 squared. So AD is the square root of 607 squared زائد or plus 143.58 squared. So the answer would be equal to 624 meters. So the length of AD is 624. Now in part C, it says Jono runs around the field from A to B, B to C, C to D, and D to A. He runs at a speed of 3 meters per second. Find the total time Jono takes to run around the field. Give your answer in minutes and seconds, correct to the nearest second. Now, we know that the equation for the time is distance over speed. Now, how can I find the distance? Now, Jono runs from A to B, B to C, C to D, and D to A. So let's go back to the diagram. He runs from A to B, which is 400, plus B to C, which is 350, plus C to D, which is 450, plus D to A, which is 624. And that was the answer to our part in, or to our part B. So the distance, it's the sum of the sides of the quadrilateral ABCD. So it's 400 plus 350 plus 450 plus 624 divided by the speed, which is 3. And the answer is, let's find that. So 400 plus 350 plus 450 plus 624 divided by 3. So it's equal to 608 seconds. And 608 seconds is equivalent to 10 minutes and 8 seconds. So that's the final answer. So 10 minutes, 8 seconds. So Jono, it takes Jono 10 minutes and 8 seconds to run around the field A, B, C, D, and back to A. Now, let's do question 6. So in part A, we need to find h of r. So how to find h of r? I need to substitute 4 into the function h of x. So h of 4 is equal to 4 to the power of 4, which is equal to 256. Then in part B, we need to find fg of 1. So fg of 1 is simply f of g of 1. And what's g of 1? I need to substitute 1 into the function g of x. So it becomes 1 squared plus 1, which is equal to f of 2. And how can I find f of 2? I need to substitute 2 into the function f of x. So it's 3 times 2 plus 2, which is 6 plus 2. And the answer is 8. So fg of 1 is equal to 8. Now, in part C, we need to find the composite function gf of x in the form ax squared plus bx plus c. Now, gf of x, so gf of x, is g of the function f of x, which is 3x plus 2. And what's g of 3x plus 2? It's simply, I need to substitute 3x plus 2 into the function g of x. So it's equal to 3x plus 2 squared plus 1. Now to find gf of x, I need to expand 3x plus 2 squared. So it's 3x plus 2 times 3x plus 2 plus 1. So let's expand these two brackets. So first I need to multiply 3x times 3x, which is 9x squared. And I need to multiply 3x times 2, which is 6x, plus 2 times 3x, which is 6x, plus 2 times 2, which is 4, plus 1. So the answer is 9x squared, 6x plus 6x is 12x, and 4 plus 1 is equal to 5. So that's the function gf of x. Now in part D, we need to find x when f of x is equal to g of 7. Now what's g of 7? So we need to substitute 7 into the function g of x. So it becomes 7 squared plus 1, which is 50. So g of 7 is 50. And what's f of x? F of x is 3x plus 2. So this is a linear equation. So I need to subtract 2 from the left hand side and 2 from the right hand side. So 3x is 50 minus 2, which is 48 over 3, and here over 3. So x is 48 divided by 3, which is equal to 16. Now in part E, we need to find f inverse x. Now what's the function f of x? It's 3x plus 2. So f of x is 3x plus 2. So to find the inverse function, the first step is to replace f of x by y. So it becomes y equals 3x plus 2. Then I need to make x the subject of the formula. So I need to subtract 2 from the left-hand side, or from the right-hand side, and 2 from the left-hand side. So it becomes y minus 2 equals to 3x. So over 3, and here over 3. So x is y minus 2 divided by 3. So to find f inverse x, I need to replace x by f inverse x, and they did that, and y by x, so it's x minus 2 divided by 3. So that's the inverse function. Great. Now in part F, it says find g of x over f of x plus x. Give your answer as a single fraction in terms of x in its simplest form. Now let's write the functions g of x and f of x. So g of x is x squared plus 1, and f of x is 3x plus 2. So g of x plus, or g of x over f of x is x squared plus 1 over 3x plus 2 plus x. Now, how can I add x squared plus 1 over 3x plus 2 plus x? So I need to have a common denominator, so I'm multiplying 1 by 3x plus 2 and x by 3x plus 2. So it becomes x squared plus 1 plus 3x times x is 3x squared plus 2 times x is 2x divided by 3x plus 2. So let's collect like terms. So I have x squared plus 3x squared is 4x squared. I have 2x plus 1, so plus 2x plus 1 divided by 3x plus 2. So that's our answer to part F. Now in part G, we need to find x when h inverse x is 2. Now what's h inverse x is 2? Now what's h of x? So h of x is, back to the question, so it's 4 to the power of x. So h of x is 4 to the power of x. So to find x when h inverse x is equal to 2, so 4 to the power of x is the same as log the power, which is x, to the base is 4, and that's equal to 2. So what's x? So x is 4, the base, raised to the power of 2, which is equal to 16. So that's the value of x.